So we're looking at let statements. Particularly, we're looking at one number problems. When your teacher tells you that you need to have a let statement, typically they're talking about the fact that you're solving word problems. Let statements allow the reader of your work to know what you're allowing your variable to stand for. That's why you write let statements. I know they seem tedious, but as you go further along in math, you're going to realize that the very process of determining your let statement actually helps your brain start to solve the problem. Early on, maybe not so much. But as you get to Algebra 2, Pre-Calculus, and Calculus, determining your let statement, that means what am I looking for? What am I trying to find? Determining that really does help you in math. So we're just going to look at some very basic problems today. There are other types of problems we'll be looking at. We have two-number problems, we'll have coin problems, we'll have consecutive integer problems, etc. But right now we're just going to start with some very simple ones. So if I read the problem, if 6 times a number is decreased by 6, the result is the same as when 3 times the number is increased by 12. Find the number. Okay, so they're asking us to find the number. That pretty much gives us our let statement. You write the word let, and I'm going to use x. You can use n. I don't care. You just have to use a variable. So we're going to let x equal the number. I abbreviate with that number sign. Your teacher may or may not allow you to do that. I have no idea. But for me, it's fine. Anyway, so now it all comes down to reading the problem correctly. If 6 times a number, stop. 6 times a number in this case means 6 times x, because we're letting x be the number. Next, is decreased by 6. Well, hopefully you know that means minus 6. The result is the same as when. That means equals. 3 times the number is increased by 12, and then we get 3x plus 12. 3 times the number is increased by 12. We've done 2 of the 3 steps necessary in solving any given word problem. The first step is to supply a let statement, and the second step is to supply an equation. Our let statement allows x to be the number, and that allows us to write 6x minus 6 equals 3x plus 12. In solving this, I choose to subtract 3x from both sides of the equation. Now, your goal is to get all the x's on one side of the equal sign and regular numbers on the other side of the equal sign. I could have subtracted 6x from both sides. That would have resulted in a negative 3x, which I'm not gung-ho about, but it doesn't matter. Either way you go is fine. 6x minus 3x is 3x. I still have minus 6, and it's going to be equal to 12. If I extend my page just a little bit here, solving this should be relatively simple for most of you. You add 6 to both sides, obviously. 3x is then equal to 18. I want to get x alone, so I divide by 3. And I get x equals 6. My advice is not to leave your answer down there at the bottom. My advice is you wrote a let statement saying let x equal the number. Now you found what x is. So go back up to the very title, to the let statement, allow x to be 6, put a box around it so that whoever comes along and reads your work can see the answer right away, even though the answer is the end of the problem, I suppose. Okay, so let's look at a second problem. If 5 times a number is increased by 50, the result is the same as when 200 is decreased by the number. Find the number. All right, this looks a lot like the last problem. I'm still going to write a let statement because it's a word problem and I have to write a let statement. They're asking me to find the number, so that's what I'm going to allow x to be. I'm going to allow x equal the number. And now it's time to decode. And that means reading the words in English and turning them into algebra. And it's pretty simple. If 5 times a number, stop, that's 5x, is increased by 50, plus 50, the result is the same as when. That means equals. 200 is decreased by the number. 200 is decreased by the number. Again, we're back to the same place. We have a let statement, we have an equation, and now all we have to do is solve. I choose to add x to both sides of my equal sign. I could have subtracted 5x. I'm not feeling that way. 5x plus 1x is 6x. Plus 50 is 200. I subtract 50 from both sides, and I end up with 6x equals 150. To get x alone, I must divide by 6. I think of this in terms of money. 150 is nothing more than $1.50, and if that's made up of quarters, it's made up of 6 of them. So 150 divided by 6 is a quarter, or 25. So x is 25. I don't want to leave my answer just down there. I also want to bring it back up into the let statement and put a box around it. Okay, so this is the basic process in setting up a let statement, setting up an equation, and solving that equation. I know you're moving from having been in elementary school and probably now you're in middle school or junior high, and this seems very algorithmic, meaning it seems like there's a lot of procedure when, Mr. Duntley, I could have done this in my head. Yeah, I understand that. But in order to progress in mathematics, you've got to be more sophisticated in your thinking and in demonstrating your work. Setting up these let statements, setting up these equations, showing the algebra is all part of becoming more sophisticated in your work. Now would be a really good time for you to pause the YouTube video, read this next problem, and try it on your own without me. So pause the YouTube, try it on your own without me, and then unpause it, and I'll show you how to do the problem. Okay, so you're back, and I'll read the problem. If 10 times a certain number is increased by 4, the result is 12 more than 9 times the number. Find the number. All right, so we'll let x equal the number. And now we'll start to decode. If 10 times a certain number, all right, that's 10x, is increased by 4, that's plus 4. The result is, that means equals, 12 more than 9 times the number. I'm going to be a stickler about this. The word than is a switch word, and that means whatever follows the word than should come first rather than vice versa. 12 more than 9 times the number should be written as 9 times the number plus 12. That's 12 more than 9x. If you flip it the other way, you're going to be okay with addition because of the commutative property, but as soon as it says 12 less than 9 times the number, then you're going to be in trouble because subtraction is not commutative and order will matter. Then is a switch word. Put the 9x first in this case. All right, so when I solve, I'm going to subtract 9x from both sides. 10x minus 9x is 1x. I've got the plus 4, and that equals 12. I subtract 4, subtract 4. I'm getting x equals 8. So back in my let statement, I write x equals 8, and hopefully that matches with what you found.